Hello friends, here in this video we will see a problem on moment of inertia for unsymmetrical I section. Here is the question that determine the MI moment of inertia for unsymmetrical I section having following details. They have given that top flange is 160 into 12 mm, bottom flange 240 into 12 mm, web is 200 into 10 mm. So these are the area given. Now the question is to determine MI, that is moment of inertia. So here we have to calculate how much is Ixx, moment of inertia about x-axis, and Iyy, moment of inertia about y-axis. Top flange, bottom flange and web dimensions are given. So these dimensions we'll use in the solution part. So let us get started. Here in the solution, here we have x and y axis. This is the axis of symmetry for the I section. Now, if we look into the question, the top flange is less in dimension compared to the bottom flange. Width of top flange is only 160, whereas the bottom flange is having width of 240. So I'll draw that in the diagram. Now, the symmetrical I section will look like this. That here there is a top flange, this is the bottom flange, and here there is web. Dimensions are: top flange is 160 into 12. So 160 mm into 12 mm. Bottom flange is 240 mm into 12 mm. Then web is 200 into 10, so the height of the web is 200 into 10. And now after drawing this diagram, it is clearly visible that it is unsymmetrical I section where the top flange is having less dimension compared to the bottom flange. But if we see in this diagram, it is unsymmetrical only about x. About y, it is symmetrical. It is clearly visible. So the first thing is we should know the location of centroid. So I'll say that since the unsymmetrical, or I can write down the I section which is given is symmetrical about y-axis. So therefore this y-axis, its distance from the origin, that will give us x bar. So x bar will be half of 240, that is 120 mm. Now after getting the y-axis for this unsymmetrical I section, the next thing is we should know where is the x-axis, and for that we should know the distance y bar. If y bar is known, x-axis is known, wherever x and y will intersect, that will give us the centroid, because without centroid we cannot proceed in the problems of moment of inertia. So now I'll say that since the location of centroid with respect to x-axis is given by y bar is equal to a1y1 plus a2y2 plus a3y3 upon area 1 plus area 2 plus area 3. I'll keep this as equation number 1. the first equation. Now I'll calculate respective areas, that is I will divide these rectangle into three simple rectangle. Here is rectangle number 1, this would be the second rectangle, and here we have the third rectangle. So rectangle 1, first I'll write down the values of area and different y values. So since area 1 is equal to 240 into 12, so area 1, it comes out to be 2880 mm square. Next area 2, it is 10 into 200, which is 2000 mm square. Area 3 is 160 into 12, that is 1920 mm square. And similarly we can get the values y1, y2 and y3. y1 will be the location of x-axis for the first rectangle. It will be at half of 12, it is 6 mm. Next y2 is the x-axis for the second rectangle, that will be 12 plus at half of 200, so it is 112 mm. Next y3 will be, this rectangle 3 is starting after 12 plus 200, so 12 plus 200 plus half of 12, so y3 value, it comes out to be 218 mm. Now after getting the respective values, we can put them in equation number 1 to get y bar. So I'll say that therefore put all values in equation number 1. So here we have y bar is equal to a1 into y1, then a2 into y2 plus a3 into y3 divided by area 1 plus area 2 plus area 3. So from this, if we calculate, the answer of y bar comes out to be 97.04 mm, and this y bar is from bottom because we have taken the references from bottom. Similarly, I can say that y bar is equal to, the total height is 224. From that, if I subtract 97.04, I will be getting the value of y bar from top, which is 126.96 mm. This is from top. So after getting these y bar values, we can plot them on the I section. From bottom it is 97.04, from the top it is more. So here, if I plot it, it will be somewhere here. I am just taking a proportionate distance. It is 97.04 mm from bottom, and from the top it is 126.96. So now mi about x-axis is given by Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. I'll keep it as equation second. Now we'll calculate individually these three values. That is, first I'll say that Ixx1, it will be calculated by parallel axis theorem. by parallel access theorem, Ixx1 will be equal to Ig1 plus area 1 into h1 square. Now, therefore, Ig1 is nothing but the moment of inertia about x-axis for the first rectangle, which is this axis. So here it is BD cube by 12 plus area 1 is B into D. Now H1. H1 is the distance between the x-axis of centroid for unsymmetrical I section and the x-axis of rectangle number 1. So this distance is H1. So here H1 will be 97.04 minus half of 12 square. So Ixx1 will be, here B and D values, B is 240, D is 12. Putting the values, this will be 97.04 minus 6 whole square. So from this, if we calculate, the value of Ixx1 will be 23.90 into 10 raised to 6 mm raised to 4. After getting Ixx1, similarly for Ixx2, we will use parallel access theorem. Ixx2 is equal to Ig2 plus area 2 into h2 square. So therefore, Ixx2 will be equal to, Ig2 is mi for second rectangle about its x-axis, and that will be, here we have B as 10 and D as 200. So it is 10 into 200 cube divided by 12, that is BD cube by 12, plus area 2 will be 10 into 200, and H2, here x-axis of unsymmetrical I section is at 97.04 mm from bottom. Similarly for the rectangle number 2, its x-axis will be 12 plus half of 200, that is 112. Suppose it is here, x-axis for second rectangle. So the distance between both of them will be h2. So h2 will become 97, it will be 112 minus 97.04 whole square, because it is 112 mm from the bottom up till here. This is 112 mm, and from that I am subtracting 97.04, that will give me h2. So Ixx2 value comes out to be 7.11 into 10 raised to 6 mm raised to 4. Now after getting Ixx2, similarly we will calculate Ixx3. So I will write down again by parallel access theorem, Ixx3 will be equal to Ig3 plus area 3 into h3 square. So therefore Ixx3 is equal to, Ig3 is BD cube by 12, area is B into D. Now h3, it is the distance between the x-axis for complete I section and the x-axis of rectangle number 3. So their distance, that is this distance will be h3. So h3 is 126.96. From that I am going to subtract 6 mm, that will give me h3. So it is 126.96 minus 6 whole square, and Ixx3 is, here B and D values, B is 160, D is 12. So Ixx3 comes out to be 28.12 into 10 raised to 6 mm raised to 4. So after getting all these three values, we can say that putting all values in equation number second to get Ixx6. So therefore put all values in equation number second. Therefore Ixx will be equal to Ixx1, which was 23.90 into 10 raised to 6, Ixx2 7.11 into 10 raised to 6, plus Ixx3, that is 28.12 into 10 raised to 6. So after adding these three values, the answer of Ixx comes out to be 59.13 into 10 raised to 6 mm raised to 4. So this is the first answer. Now after getting Ixx, I'll say that therefore mi about y-axis is given by Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. So therefore Iyy will be equal to Iyy1 dB cube by 12 for first figure, next dB cube by 12 for second figure, and dB cube by 12 for the third figure. So therefore Iyy will be equal to D and B values. If we look into this I section, for the first rectangle D is 12 and B is 240. For second, D is 200 and B is 10. For the third, D is 12 and B is 160. After adding these values, we'll get Iyy, and the answer is, it comes out to be 17.93 into 10 raised to 6 mm raised to 4. So this is the second answer. And if we look into the question, there were two things asked, Ixx and Iyy for unsymmetrical I section, and we have found out both the values, and with this we complete the question.